Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through everything you need to know for the upcoming test. It's all about quadratics. You need to be able to expand binomial expansions, factorize quadratics, and solve quadratic equations. So let's start off with expanding. So we're looking at binomial expansions, so where we have two sets of brackets being multiplied together. Each bracket has two terms, hence the name binomial expansions. So the process for expanding is the FOIL method. So F stands for firsts, so you multiply the thing that comes first in brackets. 2x times 3x is 6x squared. The O stands for outsides. So what comes outside in each bracket, so in this case it's 2x times minus 1. Then insides, the two things that occur inside the brackets, I'll do it a different color so it's not too confusing. So that would be 3 times 3x, positive 9x. And then finally the L in FOIL stands for last, the things that occur last in each bracket. So in this case 3 times minus 1, which is negative 3. So after doing that, we see if we can simplify the expression. These two are like terms, so we'll add them together. We get 6x squared plus 7x minus 3. So if I have something like this, which is a monic quadratic, it's monic because the x in both brackets has a coefficient of 1. If I want to expand this using FOIL, I go first is x times x, then O outsides is x times b, insides is a times x, and then last is a times b. So I can actually write this as x squared plus, and just factorizing this middle term. So this might seem a little complicated, but what I'm doing this for is to demonstrate to you that if you have x with a coefficient of 1 in both brackets, so this is monic, there's a quick way you can do binomial expansions. We have our x squared term. The coefficient of x is a plus b, in other words, this number and this number added together, and the constant term is those two numbers multiplied together. So let's see how we can do binomial expansions a little quicker now. So if we have something like x plus 3 times x plus 4, we have our x squared term because this is monic. The x in each bracket has a coefficient of 1. So the coefficient of x in our answer is 3 plus 4. That goes in front of x. And then 3 times 4 is the constant term that goes by itself. I have something like x minus 8 times x minus 1, x squared. Minus 8 plus minus 1 is the coefficient of x. Minus 8 times minus 1 is the constant term. So we would get these answers if we used FOIL. We just did it in a quicker way. So we can apply this quick method to perfect squares. For example, if I had x minus 3 squared, that just means x minus 3 multiplied by itself. So using our quick method, that would be x squared. The coefficient of x is minus 3 plus minus 3. Constant term is minus 3 times minus 3. So because of this, what we're saying is when you have a perfect square, like say x plus 2 squared, the quick way you can do it, you square the first, you square the second, which is always positive, and what goes in the middle is this plus itself. 2 plus 2, that's the coefficient of x. I have something like 2x minus 3 squared. So the quick way to do perfect squares, you square the first term, 2x all squared, 2x times 2x. You square the last term, always positive. The coefficient of x, the thing that goes in the middle, is 2 times this number times this term. So 2 times negative 3 times 2x, which is minus 12x. So we can apply quick methods to difference of two squares as well. If we have something like x minus 5 times x plus 5, what we were saying before, we have our x squared term. The coefficient of x is minus 5 plus 5, which is actually 0. So this is like plus 0x, and then the constant term is minus 5 times positive 5. Of course, we don't actually need to write 0x. This is just x squared minus 25. So note, what we have, when we have two brackets that have the same things inside them, but one has a plus and one has a minus, all you do is square the first, square the second, and stick a minus between them. Have something like 2x minus 7, 2x plus 7. This is the difference of two squares. Both brackets are the same, except one has a plus, one has a minus. So you square the first, you square the second, and stick a minus between them. So here we've gone through the FOIL method, but also some quick methods. We went through a quick method if the expansion is monic. We went through quick methods if it's a perfect square, and also if it's difference of two squares. Now, you don't have to use any of those quick methods if you don't want. If you used FOIL on this, you'd still get the same answer here. If you use FOIL on this, you'd still get the same answer here. It's just that FOIL takes a little longer. So if you don't understand these quick ways for monics, difference of two squares, or perfect squares, you can just use FOIL. All right, let's get on now to factorizing. So we're looking at quadratic expressions. So these are things that have an x squared term. And now what we're doing is factorizing. So note on the previous slide we were expanding. That's when you start with brackets and you end up with something that doesn't have brackets. Here we're doing the opposite. Factorizing means you start off with an expression and you end up with some brackets. So when we're factorizing, we're taking something like this and writing it like this, as something times something, the product of factors. And this is very important when solving. So it turns out we factorize quadratics slightly differently depending on what the quadratic looks like. So the quadratics we have could be a binomial quadratic, which means it has two terms, or a trinomial quadratic, which means it has three terms. And for this test, only the 10A people are doing non-monic quadratics. So for binomial quadratics, you'll either use highest common factor, difference of two squares, or both. They're the methods when you have only two terms. For trinomials, on the other hand, we need a different method. It doesn't really have a name, but what we're going to do is we're going to find two numbers that times to the constant term, the term by itself, and add to the coefficient, which means number in front of x in this case. You need to be able to identify which type it is. So for binomials, let's say I have the highest common factor would be something like this, x squared plus 6x. So this is one term, x squared, and this is another term, positive 6x. So that's why it's a binomial. Now, highest common factor means I have to find the highest thing that goes into the first term and the second term. That turns out to be x. So x goes into both terms. So what I do is I take the highest common factor out of the brackets. Now, inside the brackets, I say, what do I times by x to get the first term? What do I times by x to get x squared? That's just x. What do I times by x to get positive 6x? And of course, that's just positive 6. And that's my final answer. Note that if I expand this, I will get my original answer. So difference of two squares is something we talked about when we were expanding. In fact, this is the difference of two squares. It's when you have a square minus another square. So like x squared minus 16 is the difference of two squares. Difference meaning minus, and it's a square. X squared's a perfect square, and 16's a perfect square. So then, what we do here is just the opposite of what we did when we were expanding. We have two brackets, you square root the first, so the square root of x squared is x, square root of 16 is 4, one bracket gets a plus, and one gets a minus. Now this is the answer, because if I expand this using FOIL, I will get this. Let's look at another example. So 4x squared minus 81, it's the difference of 1, so 4x squared is one square, 81 is another square, difference of two squares. So we get our two brackets, Square root of 4x squared is 2x, because 2x times by itself gives 4x squared. Square root 81. 1 gets a plus, and 1 gets a minus. So note that in each of these, they were binomials as they also had two terms. So sometimes you'll need to use both. So for example, if you've got something like 2x squared minus 98, the problem is we've only got two terms, so this is a binomial. We can't use difference of two squares because 2 is not a perfect square, nor is 98. But 2 and 98 have a common factor, so we write the common factor out the front. So the highest common factor of 2 and 98 is 2. What do you times by 2 to get 2x squared? What do you times by negative 98? But we're not done here because this can be factorized. What's in the brackets? It can be factorized again because it's the difference of two squares. So we keep our 2 out the front, difference of two squares, square root the first, square root the second. 1 gets a plus, 1 gets a minus. This time we wrote the binomial as the product of 1, 2, 3 factors. So we still factorized. So trinomials have three terms. So there'll be things like x squared plus 8x plus 12. So we're just going to undo what we did with FOIL. Remember that when we were expanding, we had brackets like this with an x in each bracket. And the numbers that go here and here are two numbers that add to this and multiply to this. So the two numbers that add to 8 and multiply to 12 are positive 2 and positive 6. So that is our answer. It's now been factorized as something times something. So let's look at x squared minus 7x minus 60. Once again, it's a quadratic trinomial. We've got 1, 2, 3 terms. So we want to find two numbers that multiply to this term, which is negative 60, and add to negative 7. So if you're stuck, go through factors of 60. Now, because both numbers have to multiply to a negative, in this case, one's going to be positive, one's going to be negative. So if you go through factors of 60, we strike gold when we come to 12 and 5. They need to add to negative 7. So it needs to be negative 12 and positive 5, and we're done. Once again, if I expand this using FOIL, I get back what I started. Let's now look at using this to solve quadratics. When we're solving quadratics, we'll either use factorization or the quadratic formula. So let's say we wanted to solve this. X squared minus 36 is equal to 0. So what we do is we factorize this expression. So this is a binomial. It's the difference of two squares. So square root the first, square root the second. 1 gets a plus, 1 gets a minus. So by factorizing, we're able to use the null factor law. So here we have an equation because it has an equal sign. We have something times something is equal to 0. So the null factor law says either the first bracket is equal to 0. So if x plus 6 is equal to 0, x equals minus 6. The null factor law says either the first bracket equals 0 or the second bracket equals 0. So if the second bracket equals 0, x would be positive 6. So the two solutions to this are positive and negative 6. We can usually write it like this, plus or minus 6. So that's the first one solved. So now we have another equation. This has a quadratic binomial, two terms, 4x squared and negative 28x. So this is not the difference of two squares, it's highest common factor. So the highest common factor is 4x, that goes out the front. What do I times by 4x to get 4x squared? X. What do I times by 4x to get negative 28x? And negative 7. So we use the null factor law, either the first thing or the second thing equals 0. If 4x equals 0, you're saying 4 times a number equals 0, then x equals 0. X equals 0 is one solution, or the second bracket equals 0. If x minus 7 equals 0, x equals 7. So the two solutions here are x equals 0 and x equals 7. So sometimes you'll get some weird brackets to solve. So if you had something like 2x minus 3, 4x plus 1 equals 0, you can still use the null factor law. Either the first thing is equal to 0. This is just a linear equation. We just solve that like we normally do. Add 3 to both sides and divide each side by 2. So 3 over 2 is one solution. Or the other solution is 4x plus 1 equals 0. Subtract 1 from both sides and then divide by 4. So in this case, the solutions would be 3 over 2 or negative a quarter. Let's now look at an equation that involves a quadratic trinomial. So let's say I have x squared plus 7x plus 10 is equal to 0. Now what you might notice here, we're not treating this like a linear equation. We're not going to subtract 10 from both sides and then divide by 7. Do not try to solve quadratics like linear equations because you'll be there all day and you won't get anywhere. You must either factorize or use the quadratic formula. They're the only methods we have. So I'm going to factorize. We're going to factorize this expression. So we need two numbers that times to positive 10 and add to 7. If you don't know what they are, just go through factors of 10. You get x plus 5 and x plus 2. So they're the two brackets. So either the first bracket equals 0, if x plus 5 equals 0, x is minus 5, or the second bracket equals 0, which would mean x is minus 2. And they're the two solutions. All of the quadratics we've looked at so far on this slide have two solutions. So quadratics often do have two, but they might only have one solution as well. So if you have something like x squared minus 12x plus 36 is equal to 0, if we go factorizing this expression here, the two numbers that multiply to 36 and add to negative 12 are both the same. They're both negative 6. So this is an example of a quadratic that has one solution. Because if the first bracket is equal to 0, then x is positive 6. But if the second bracket is equal to 0, x is positive 6. So this has only one solution. In fact, all quadratics have 0, 1, or 2 solutions. We've seen all these examples where quadratics have 2 solutions. We've now seen an example where they sometimes have one solution. Now let's look at an example where they have no solutions. Please pause and copy this down if you need. So let's say I wanted to solve x squared minus 4x plus 6 is equal to 0. Now, you can't factorize this expression because the method I gave you was two numbers that times to 6 and add to negative 4. But it turns out there aren't any such numbers. There aren't two numbers that add to negative 4 and multiply to 6. You could sit here all day and you won't get anywhere. So we need another method of solving quadratics because not every quadratic can be factorized. And that other method we have is the quadratic formula. So this is the quadratic formula here. Now it is full of B's and A's and C's. What they mean is A is the coefficient of x squared, B the number in front of x, and C the constant term. You simply substitute those values into this formula. But the formula is a little more complicated than most. So when you're using the quadratic formula, my advice is to first calculate the discriminant. So the discriminant is that part under the square root sign. So the reason we calculate that first is it will tell us how many solutions. Now, if the discriminant is less than 0, there will be no solutions. Less than 0 means negative. If this thing here is negative, you're trying to square root a negative, which you can't do. You can't have the square root of minus 1 or the square root of minus 2. That's why discriminant less than 0 means no solutions. Now, if the discriminant is equal to 0, there will be one solution, like in the example I gave you on the previous slide. That's because the square root of 0 has only one possibility. So if the discriminant is greater than 0, there will be two solutions. That's because when you square root a positive number, there are two solutions. Like square root of 4 is positive 2 or negative 2. So going back to our example up here, we would first try and use the discriminant when we realize we can't factorize it. So the discriminant here is b squared. So b is the number in front of x, b squared minus 4 times a is the number in front of x squared, which is 1. X squared and 1x squared are the same thing. B squared minus 4 times a times c is positive 6. So minus 4 squared, you always have to, in your calculator, if you want to square a negative, you must put it in brackets. So I would get positive 16 minus 24, which is negative 8. So the discriminant for this equation is negative. That means it will have no solutions. That's why we couldn't solve it. So the quadratic formula is also very useful because it will tell us when there are weird solutions like 1 plus or minus root 3. So it turns out that x squared minus 4x minus 3 equals 0 is one such equation. Probably looks like you could factorize it, but you can't actually find off the top of your head at least two numbers that add to negative 4 and multiply to negative 3. You'll be there all day. So we're not going to try and factorize it. Instead, what we're going to do is use the quadratic formula. So here, if I calculate the discriminant first, b is again minus 4, so I get b squared minus 4 times a, the number in front of x squared, times c. That actually gives me positive 28 this time, so this equation will have two solutions. We're now going to go ahead and use the quadratic formula to find those solutions. So the solutions are x equals minus b, so minus minus 4. This symbol means plus or minus the square root of the discriminant, all divided by 2 times a. So the two solutions that we're talking about, we have minus minus 4, positive 4 plus root 28 over 2. And we have positive 4 minus root 28 over 2. So these can actually be simplified. It doesn't matter too much if you don't do this in the test. I just want to show you why these are the two numbers. So these can actually be simplified as 2 plus or minus root 7. They're the two solutions. 2 plus root 7 and 2 minus root 7. So it turns out that you can find numbers that multiply to this and add to this. Those two numbers will be negative 2 plus root 7 and negative 2 minus root 7. But there's no way you could have come up with those off the top of your head. That's why we need the quadratic formula. The thing that's good about the quadratic formula is that it will allow us to solve quadratics that are non-monic, where the number in front of x squared is not equal to 1. So let's go ahead and calculate the discriminant. So it will be b squared minus 4 times a times c. Now, it turns out in this case, you get 0 if you put that on your calculator. Once again, remember, if squaring a negative in your calculator, it needs to go in brackets. So this means there's actually only one solution to this equation. Let's find out what it is. So using the quadratic formula, we have x equals minus b, so b was negative 24, minus b plus or minus the square root of the discriminant over 2 times, which was 16. So the only solution here, we've got 24 plus 0 over 32 or 25 minus 0 over 32. And they're the same thing, because 24 plus 0 and 24 minus 0 are the same thing. The only solution is 24 over 32, which is 0.75. Once again, it would be really hard to try and factorize this, so that's why the quadratic formula is useful. All right, the last thing we need to go through is solving worded problems. So for our first example, we're going to try and find numbers so that when you square them, it adds 30 to them. Or in other words, numbers whose square is 30 more than the number. So whenever you have a worded problem, you always start by defining a pronumeral, and we only ever want to use one pronumeral. So you always let x equal whatever we're trying to find. In this case, we're trying to find some number, so let's just let x be the number. The next thing we do is turn this into a quadratic equation. So there should be an x squared term somewhere. So what we're saying is if we square a number, that's the same as taking the number and adding 30. So we're rewriting all of these words concisely with mathematical symbols as an equation. Once we're there, we can just solve this using the processes we just used. Now, this quadratic equation here looks a bit different because one side is not equal to 0. We only know how to solve quadratics when one side is equal to 0. So first we need to get one side equal to 0. So what we're going to do is we're going to subtract x from both sides, and then we're going to subtract 30 from both sides so that one side is equal to 0. So now this equation looks like all the others. So what you can do is factorize or use quadratic formula. So if I were to factorize, I want to find two numbers that multiply to negative 30 and add to negative 1. So those numbers turn out to be minus 6 and positive 5. So if this is the factorized expression, the two solutions, either the first thing equals 0 or the second thing equals 0. There are two solutions here, x equals 6 or minus 5, because both of them, when you square them, adds 30 to them. If you square 6, you get 36. If you square negative 5, you get positive 25, which is 30 more than negative 5. So let's look at another worded question. So, rectangle has a length that's 4 centimeters more than its width. Area 165, we will find its dimensions. So we always start by letting x equal something we're trying to find. Now in this case, the dimensions mean we want to find its length and its width. We don't want to let x equal the length and y equal the width. We only wanted to find one pronumeral. So let's let x equal the width. Then the length will be x plus 4. So it's in terms of x. So we know that the area of a rectangle is just width times length. And that area we're told is 165. So now we've got our equation. We just solve it. We want to get one side equal to 0. So we'll start by expanding the brackets. And then what we're going to do is subtract 165 from both sides. So if I wanted to, I could factorize this, but it might be hard for you in a test to try and find two numbers that multiply to negative 165 and add to 4. It can be done, but it's not easy to do. So instead we might use the quadratic formula. So first I calculate the discriminant, b squared minus 4ac, and I should get 676. So now I go through the quadratic formula. X equals minus b plus or minus the square root of the discriminant over 2 times a. Two solutions here. The first solution is x is minus 4 plus root 676 over 2, so that's minus 4 plus 26 over 2, which is 11. The other solution is minus 4 minus root 676 over 2, and that gives me negative 15. So there are two solutions again, but I only accept one. See, in the previous example, it just asked for a number. Didn't matter whether the number was positive or negative. But here, we're talking about dimensions. So I can't have a negative value for the width because x is the width. So I reject that solution. So what must happen is that the width is 11 centimeters and then the length would be 15 centimeters. And then I just write a worded answer to a worded question like that, and then I'm done. All right, I'll just do one more quick example. So this question here is that the longest side of a right-angled triangle is 18 centimeters longer than the shortest side, 1 centimeters longer than the other side. We're going to find the perimeter of the triangle. This is a bit harder because you have to realize that you're using Pythagoras. But we're not going to do this any different to start off with. We're going to let x equal something we're trying to find. Now, we're not going to be able to find the perimeter directly. So what we're going to need to do is let x be one of the sides. So let's let x be the shortest side, or the length of the shortest side. Now, we have information about the other two sides, but we don't want to use a different pronumeral, a different letter, because we won't be able to solve the equation. We need to write them in terms of x. So if x is the shortest side, then x plus 18 is going to be the length of the longest side. And that means because it's 1 centimeter longer than the other side, then the other side will be x plus 17. This is a quadratic because of Pythagoras. Theorem, shorter side squared plus shorter side squared is equal to longer side squared. So to solve this, we're going to need to expand all the brackets. Lucky we went through FOIL. So x squared. Now the quick way to expand perfect squares again is square the first, and we square the second. 17 squared is 289, and in the middle goes twice the product of the two things in the brackets. 2 times 17 times x. And we do something similar on the right-hand side. Square the first, square the second, and in the middle goes 2 times 18 times x. So we've got x's and stuff all over the place. Let's collect like terms on the left-hand side, and then what we're going to need to do is get one side equal to 0, because we cannot solve quadratics unless one side is equal to 0. So to do this, I'm going to subtract x squared from both sides. I'm now going to subtract 36x from both sides. And I'm now going to subtract 324 from both sides. So now that I've got one side equal to 0, I can solve. You can factorize or use the quadratic formula. It's up to you, depends whether or not you can see that there are two numbers that multiply to negative 35 and add to negative 2. So those numbers are minus 7 and positive 5. So I've done it by factorization. Like I said, you could have used the quadratic formula. So the two solutions here are x equals 7 and negative 5. But once again, we are talking about lengths, so I've got to disregard the negative answer. So x equals 7, that means the shorter side is 7. That means the longer side is 25, the other side is 24. And that works because 7 squared plus 24 squared equals 25 squared. So therefore, the perimeter, you're just going to add them all up. I know you know how to do perimeter, and of course, it will be 56 centimeters, and we're done. All right, sorry for the long video. Best of luck in the test, but you're a superstar. You'll ace it. Make sure you ask for any help if you need. Otherwise, this has been the luckiest maths teacher in the world. Have a great day and look forward to seeing you ace the test.